Hello friends, I welcome you all on India's largest live e-learning educational platform, that is Gradeup. Friends, today we are going to take the topics which we were supposed to complete yesterday, that we'll be continuing from the yesterday's topic, and after completion then we'll be going to the basic construction of transformer. Now before I start the session, all of you who are joining me for the session, quickly tell me whether my audio and visual quality is okay for you. Until that time, let me list the topics that we are going to cover today. The first topic that we are going to cover today is EMF induced in induction machine. Then we will see EMF induced in DC machine. Then we will see the torque, basically for non-salient pole machine. We are simply trying to understand the non-salient pole type machine here is because the salient pole type machine, that understanding is little complex and it requires some more information also. So when we will be dealing with the salient pole synchronous machine, then we will discuss about this in detail. I hope it is clear to all of you. Now, all of you who are joining me, please tell me quickly whether my audio and visual quality is okay for you. Anyone out there, please tell me whether my audio and visual quality is okay for you. Can we proceed? Okay, so let the people slowly join the session and let us start the session. And meanwhile, if there is any problem related to my voice quality or visual quality, then you can report me. Hello, Mr. Kiru, how are you? Okay, so it is okay. Now let us proceed. The first slide on your screen shows how to wash your hands, how so that you protect yourself and others against the infections related to the novel coronavirus. This is the initiative started by Team Gradeup as hashtag prep smart stay safe. So the steps for washing your hands properly is you should wash your hands with the direct tap water, apply soap, rub hands palm to palm, gather the backs of your hands, scrub between your fingers, rub the backs of the fingers on the opposing palm, clean thumbs, wash fingernail, fingertips, then wash your hands under the direct tap water, dry it using a towel and switch off the tap by using a tissue paper or the towel, and now your hands are clean. And as per the government regulations, this procedure should approximately take 20 seconds around. Okay. Now the next slide on your screen shows the contact number for the control room which is being set up at the national level to address the queries related to the novel coronavirus. You may reach this number for any guidance, support and technical queries. This also we are communicating under the initiative hashtag prep smart stay safe as started by Team Gradeup. Now before I start this session, a very important information for all of you that in this time when everybody is secluded in their home, the Gradeup is offering to you free of cost classes on the Gradeup classroom. And let me tell you, if you are really serious about your career, your preparation, then these classes are meant for you and they are very important for you. For example, for electrical engineering students, I am telling M.N. Ramesh Sir, Chandan Jha Sir and Rakesh Talleja Sir, they are taking Engineering Services 2020 mains practice classes 9 a.m. in the morning. Chandan Jha Sir is taking concept on fingertips classes at 12 p.m. I am taking Engineering Services 2021 prelims free classes for paper 1 at 1 p.m. where I am teaching ethics. Already for this, I think more than 20 lectures are already there on the playlist. So if you are interested, you can go for it. This engineering ethics class I am taking every day, Monday to Friday at 1 p.m. on the Gradeup app. BYJU'S sir is taking concept on fingertips classes at 2 p.m. M.N. Ramesh sir is taking concept on fingertips classes at 7 p.m. Good evening, Vigneshwar, Sai Kumar. How are you? 2021. The most important feature of this batch is that it is going to be a bilingual course. Bilingual means हिंदी और इंग्लिश दोनों में बातचीत होगी इस बैच में, जिससे कि so that your learning becomes easy for you and language is not a barrier. In this batch, Rakesh Talreja sir, ME, ISC Bangalore, AIR 09, 10 plus years of experience. Myself, Ashutosh Saxena, M.Tech, IIT B.H.U, 10 plus years of experience. MN Ramesh sir, ME, Osmania University, Hyderabad, 17 plus years of experience. Vijay Bansal sir, 19 plus years of experience. Chandan Jha sir, M.Tech, NIT Hamirpur, 9 plus years of experience. And so many people have started the free trial. Even if you are not interested, at least you should start the free trial. Lot of interesting classes are being conducted in this, so you can go for it. Thank you, Sai Kumar, for your appreciation. It is good that you are getting something out of our efforts. This is our idea. This is our intention that we should always try to enhance the learning and make learning for our students easy and comfortable. Now let us focus on the topic. So first of all, we are going to discuss the EMF induced in induction machine. Now yesterday we were discussing the basic idea about induction machine, and all of you who have not attended that class, you can go to the Gradeup YouTube channel playlist and you can watch that video and it is going to be helpful for you. Hello Shiva Prasad, how are you? So the first thing is we want to see the EMF induced. The first part that we want to see is EMF induced in the stator winding. Okay. Shiva Prasad is saying, sir, how to prepare for transformer for AC point of view in electronics. Okay, Shiva Prasad. So you are asking for electronics. So, beta electronics, I think in general, if you follow my lectures, then the basic understanding you will develop. 45 minutes daily, if you can devote, then it is going to be more than sufficient for you, even for electrical also. Yes, Sai Kumar, I cannot assure you whether the complete syllabus is going to be covered or not because it depends on number of classes we are having, what is the exact schedule. But for each month, at least 1 month, the day when we have started, approximately for 1 month, the classes are going to be running. So after that, if the time is permissible, then definitely we'll go ahead. Our idea is that we give a kind of enhancement to the learning of the student so that learning becomes easy for you and you get interested in the subject. That is our idea. I hope it is clear to all of you. Lot of interesting things we are going to discuss here. Hello Ganesh, how are you? I hope Sai Kumar, I have answered your query. Now before I start the session, it is very important that a lot of people have joined the session that you please make it a habit to like this session at least, even if you don't share it. But the best thing is you like it and you share it in your social media platforms because lot of efforts we are putting in to bring these lectures to you, and it is a kind of feedback for us that we should keep on making such videos for you or not. So I think there is no time is invested in just liking the page, so you all should keep on liking the page quickly. I hope you have no issue with this. I can see the number of likes are very less. Can't you increase the number of likes? Anyways, now let us focus on the class. All of you who have not liked the session, quickly like the session, and all of you please focus here. So first we will be seeing the EMF induced in the stator winding. Now you must be knowing that if you see an induction machine, let me give you one small brief introduction. That three-phase supply, I am talking about a three-phase induction machine. Three-phase induction motor, three-phase supply is given to the stator. Okay, this is your stator and this is your rotor. Now stator is having a three-phase 120-degree displaced winding. So our first effort is to find the EMF induced in the stator winding. Now please try to understand here. The induction machine is very similar to the transformer with some basic differences. Okay, now what are the differences? The basic differences is that your transformer is going to be a static device, whereas your induction machine is going to be a rotating device. All these points we are going to discuss when we are going to discuss the induction motor or induction machine. You don't worry here, but the basic idea is that if you see your induction machine is very similar to the transformer. So if you see the stator winding induced EMF you can very easily write as you write it for the transformer. So it is going to be root 2 pi f kW. What is kW? That is the winding factor. NPHS. What is NPHS? NPH is the number of turns per phase of the stator winding. And this is going to be flux. So this is the equation. Now Sanjay, please wait, don't worry about that comparison. We'll discuss that in detail when we will discuss about the induction machine or the transformer. Those differences we will discuss. Don't worry here. Now just focus here. So this is in general you can say the equation for induced EMF in the stator winding. Now let us see the EMF induced in the rotor winding. Second part we have to see is the Now you please pay attention here because it is really going to be interesting. Till now we have seen the equation for induced EMF, okay, and that we have derived for general rotating machines, and that we have seen the special cases of synchronous machine. Now we are discussing the induction machine. Now if you go to the induction machine, in case of induction machine, the most remarkable, the most basic difference feature in comparison to other machines is that your induction machine is going to have a slip. What is that slip? How you are defining the slip? We are defining the slip. Please try to understand. The rotor of the induction motor runs just behind the synchronously rotating stator magnetic field. I hope it is clear too. What is the meaning of this? The meaning of this is if NR is the rotor speed and NS is the stator rotating magnetic field speed, then you can say that NR is very close to NS, though always less than Ns for motoring action. For motoring action. What is this motoring action? Yes, RD, you are perfectly right here. So, if you want to write the EMF induced in case of a rotor of induction machine, then you can write it like this. I am writing it, you please confirm here. I am writing the instantaneous value. So, this is going to be N omega minus omega R phi. This is going to be sine omega minus omega R t. What we have done? We were saying in the previous case, we were using omega R, and for induction machine, we are using omega minus omega R. Because previously we were saying omega R is the relative speed, but omega minus omega R is the relative speed in case of induction machine. So we are using omega minus omega R. Now the rest of the things are very easy. Now you can simplify it. If you put the winding factor and everything, including the winding factor and everything, if you put it, including the winding factor, so this E is going to be, EMF induced is going to be NPHR. What is NPHR? Number of turns per phase for the rotor winding. This is going to be omega minus omega R, that is the relative speed. This is the winding factor. This is going to be phi sine omega minus omega R t. Now from here, you please understand the basic idea of slip speed. Of simply slip. Slip we are defining as Ns minus Nr upon Ns. So similarly, you can define slip as omega minus omega R upon omega. So you can write omega minus omega R as omega multiplied by slip, yes or no? So we are going to replace omega minus omega R by using omega S. So what is going to happen? So you are getting the equation something like this. It is going to be E is equal to S omega N phase R, that is the number of turns per phase for the rotor winding. This is going to be the winding factor, this is flux, and this is going to be sine S omega t. Now if you are having this equation, then you can find the RMS value the way we have found in the previous discussion yesterday. So the RMS value of this EMF induced is going to be how much? This is going to be root 2 pi. One new term is going to come, that is F. Instead of FR there, you are writing SF. And this is going to be winding factor, number of turns per phase for the rotor winding, and the flux. So this is the equation for the EMF induced in the rotor winding of an induction machine. Now all of you please tell me, are you comfortable with this? All of you quickly tell me, are you able to follow this? All of you who have studied little bit of induction machine, you must remember that in general we write the EMF induced in the rotor winding E2S as slip times E20, where E20 is the EMF induced at the standstill. Similar expression you are getting, but this is the fundamental way to understand why it is so. I hope it is okay to all of you. And all of you who have not attended my previous session, it is going to be little difficult for you to understand it directly, because we are drawing some analogy and it is not possible to derive everything every time. But if you are following the previous lectures, then it is going to be easy for you to understand. I hope it is clear to all of you. Now suppose, let us take one more case. If the rotor is rotating in the opposite direction, the rotor is rotating in the opposite direction, then what is going to happen to that of the rotating flux? Then what is going to happen? Please tell me. Instead of omega minus omega r, you are going to write omega plus omega r, because then relative speed is going to be omega plus omega r. So what is going to be the equation? Please tell me. It is going to be, EMF induced is going to be omega plus omega r. This is going to be N PHR kW phi, and this is going to be sine omega plus omega r, and this is going to be T. Now you just focus here. What is omega plus omega r? What is omega plus omega r? You must be knowing omega r is omega, you can say 1 minus s, yes or no? So you can take omega common, so it is going to be 2 minus s. Now just put omega plus omega r as omega 2 minus s here. So it is going to be, the equation is going to be how much? E is equal to omega 2 minus s, and this is going to be NPHR, and this is going to be kW phi, and this is going to be sine 2 minus s omega t. So this is the equation we are using for EMF induced in case of an induction machine if the rotor is rotating in the opposite direction to that of the synchronously rotating magnetic field. Now let us try to see the RMS value. Here only we are going to see the RMS value. Very short I am writing this. Very short I am writing this. So you are getting the RMS value. Just see it here. It is going to be, I am writing it with a different color so that you can understand it. The RMS value is going to be in that case root 2 pi f, and instead of s it is going to be 2 minus s, and rest of the things are going to be same. Winding factor and flux. This is the RMS value. Now what is the idea? The idea is, if you see, the frequency of the EMF generated in the rotor circuit is going to be actually 2 minus SF. I hope it is clear to all of you. It means you can say that a polyphase induction motor can be used as a frequency converter or frequency changer. What we can write? Let me write it here so that you can remember it. I am writing it here. I am removing a little bit of content. I hope you have noted it. The very interesting feature of induction machine is that it is important in engineering services. This point can be directly asked. It is going to be important. A polyphase induction machine can be used as the frequency converter so that supply frequency is changed to slip ring frequency. This we are calling it slip ring frequency or slip frequency. Any name you can give. RD, Mr. RD, it is not needed that you type the equation in the comment, beta. It is not needed. Don't become emotional out of it. Okay? Just try to understand things from the point of view which is required. I hope you are able to follow this. Now let us try to understand the EMF induced in case of a DC machine. I hope it is clear to all of you. Now see, the different details we are going to see when we are going to actually read this DC machines. When we will start, then we will see. But the basic idea you all must be having. And what is that basic idea? That basic idea is that your DC machine is nothing but AC machine plus commutator. We will try to understand when we will discuss DC machine, what is commutator, what is slip ring, what is split ring, all these details we are going to discuss. Yes, RD, perfectly right. You are right here. So, what is the idea behind this statement that DC machine is nothing but AC machine plus commutator? The idea here, my dear, is that the armature winding in a DC machine carries AC current. Okay? What is the meaning of this thing? The meaning of this thing, if you see at the coil level, suppose we are considering the coil AA dash. At the coil level, if you want to see, suppose if the voltages are like this, let me draw it here. Okay. Now suppose this is omega RT, and this is the voltage induced in coil AA dash. It is going to be alternating, yes or no? Then only the currents in the armature winding is going to be alternating. But if you see the voltage across the brushes, suppose it is V1 and V2, then it is going to be something like this. The diagram is not that good, so don't worry, but I think you will understand the point. The point is that it is going to be only single polarity, though there are going to be some ripples, that we will see how to remove them, how to reduce the ripples. Sanjay, Bontu, I am not getting your doubt. What is your doubt, beta? What you want to say? That is for motor RD. So, the idea is, if you are having this type of voltage across the brushes, my voice is low, okay. Now it is okay. Now my voice is okay. Please tell me. Ramanand, please tell me whether my voice is okay now. Is it clear? Now please try to understand the EMF equation that we have derived. The EMF induced in a coil at any time t. It is going to be given by, suppose EC, for a coil we are saying it is going to be N omega R. This is going to be phi sine omega R t. I think now it is okay. Now, if you are getting the voltage across the brushes something like this, so this is 0, this is pi, this is 2 pi. So if you want to find the average value, We are interested in the average value or DC value. Average value is nothing but the DC value. So if you find the DC value for this voltage which is coming across the brushes, what you are going to do? You are going to integrate it from 0 to pi, yes or no? And the duration of the time period for this 0 to pi is pi. So how you are going to write it? Please tell me how you are going to write the average value for the EMF induced in a coil. The average value, we are writing it as average value of EMF that is the voltage across brushes, and that is going to be given by 1 by pi, and it is going to be integration 0 to pi. Put the value here, n omega r pi. This is going to be sine omega r t, and this is going to be d omega r t. I hope it is clear to all of you. And the average value you can easily find as 2 times n omega r pi divided by pi. I hope you are okay with this. Yes or no? Say this is equation number 1, or you can say like this. Now you focus here. What is omega r? Omega r is actually the armature speed in electrical radian per second. Yes or no? So now we want to write the omega r value. What is omega r? Omega r is going to be 2 pi fr. And you know what is fr? Fr is going to be how much? It is going to be Pn by 2. You remember this formula or not? F is Pn upon 120. So if you keep n is equal to, small n is equal to n by 60, so this F is going to be Pn by 2. Here n is in RPM, revolutions per minute, where this small n is in RPS, that is revolutions per second. So we are writing Fr as Pn by 2. If you put the value, so you will be getting omega r as 2 pi. What is Fr? It is Pn by 2. So this is going to be omega r is equal to pi Pn. Okay. Now this value we are going to put in the equation. So if you put the value, then you will be getting E as Pn phi Z. Now what is this Z? Z is the total number of conductors, where the total number of conductors are going to be 2 times the number of turns. Because if you see one turn is going to give you 2 conductors. So n turns are going to give you how much? Z is equal to 2n conductors. So if you put this omega r value and this Z value like this, so you are going to get in average EMF across the brushes, the voltage as this much. I hope it is clear to all of you. Now we are interested to find the average EMF per conductor. Yes or no? Because if you know the average EMF per conductor, then very easily we can find the total EMF induced. Yes or no? So this is going to be 1 by Z, and this is going to be Pn phi Z. So Z is going to be cancelled. So you are getting the average EMF per conductor as Pn phi. I hope it is clear to all of you. I hope that you are comfortable with this equation. Average EMF per conductor is Pn phi. You must remember this value also. Yes, yes, Sanjay, you are perfectly right here. Now you see, now let us go inside the armature of the DC machine and try to see how we are going to find the total EMF across the brushes. Now just see here. Suppose this is your DC machine. Just try to imagine this is your armature of the DC machine, and it is going to be something like this. I hope you can visualize the inside of the armature of the DC machine. These are different parallel paths. When we will discuss DC machines in detail, then we will discuss but I hope that this much you must be able to understand that what is happening here. Now please try to understand each conductor is replaced with EMF, EZ and resistance small r. I hope you are getting this. So these are the number of parallel paths. These are the number of parallel paths. Number of parallel paths. And this we are denoting with A. I hope it is clear, and you must be knowing that for lap winding and wave winding, for different constructions, we are having different values of this number of parallel paths. In general, we say that for wave winding we are having A is equal to 2 for wave winding, and we are having A is equal to P for lap winding. This we will discuss in detail when we will discuss the DC machines in actual. Okay. Now please try to understand, if there are a parallel path, so can you tell me what is going to be the EMF across the brushes? Suppose the brushes are placed here. These are the brushes. This is B1 and this is B2. Can you tell me the voltage across these brushes? Yes or no? If you find the voltage in a parallel path, then it is going to be voltage across the brushes, because for parallel combination the voltage is going to be same. So if you are having the EMF induced in one conductor, so the only thing which is remaining is the number of conductors in one parallel path. Can you tell me what is the number of conductors in one parallel path? Total number of conductors divided by the number of parallel paths. So very easily you can write the EMF induced E as EMF per conductor multiplied by conductors in a parallel path. Yes or no? So this we have found as P and phi, and this is nothing but Z by A, and N you can write as capital N by 60. So if you put the values, so you will be getting your very favorite formula, that is Z phi N upon 60 P by A. So this is the formula you generally remember for your DC machines. This is very, very important, and I hope it is clear to all of you. All of you, please tell me whether it is okay for you, and if you have any doubt, then you can ask me. Is it okay for you, or you have any doubt? Please tell me quickly. Okay, so now let us proceed. Before that, there is some important information which I wanted to convey to you. Let us see what is that important information. This is regarding the Target Gate 2021 batch. It is going to be a bilingual course. That is the first thing that we have discussed before we start the class. Now, how you should enroll this? Because let me tell you that scholarship for this, we are going to take one examination that we are calling as GEST. It is going to be conducted on 11th May. So GEST is going to be conducted on 11th May. But if you want to avail the scholarship, you should get registered or enrolled, and this is how you should enroll. You should go to the buy now section, select the monthly installment options, and you proceed to pay only 1000 rupees, and you can get access till 15th of May. And remaining things, I think they are easy. And for any query, you can contact this number or you can contact this email ID, and our backend team member Anand Pandey is going to. Ramanan, beta, I am not getting your doubt. What is your doubt? Please tell me. Okay, so there is some highlights of the Target Gate batch. It is going to be a bilingual course. If you want to avail the scholarship, you have to appear for the GEST, that is the Gradeup Engineering Scholarship Test. You should enroll before 25th of April. This is very, very important. You can attend live classes, appear for GEST, know your rank, and the remaining amount, if you are not getting any scholarship. If you are getting the scholarship, then it is going to be good. If not, then you can pay the remaining amount in easy EMIs. So all these details you can find on the Gradeup app. I hope it is clear to all of you. Okay. Now let us try to understand and start with this electromagnetic torque. Let us try to understand what is this electromagnetic torque. Okay. Now let us take a simple two-pole machine. I am going to start with a simple two-pole machine. Okay, you just wait for some time, because let me draw the figure so that you understand it better. Suppose you have a two-pole machine like this. Okay, so these are the two poles of the machine. Suppose this is north pole and this is south pole, and suppose this is your rotor. Okay, now see what is going to happen. Please try to understand. Suppose there is a conductor, and there is a current direction like this. It is having a current direction out of the plane of the board. What is the direction of the magnetic flux? The magnetic flux direction is going to be something like this. Yes or no? And when the current is going to be present in this conductor, there is going to be some distortion in this main field flux. Yes or no? But when this conductor is having a current in an external field, that is the field due to this field poles, then definitely some torque, some force is going to be appearing on this conductor. And you must be knowing that whenever you want to find the direction of force, you have to use the left hand Fleming's rule. So what is the idea? The idea is, I am writing it here, please note it down. When a current carrying conductor is placed in an external magnetic field, a force is exerted on the conductor the direction of the force is given by Fleming's left hand rule. What is that left hand rule? That we are going to discuss in detail. Love Chaurasia is asking, sir, that is A armature. Now see, Love Chaurasia, how we have defined till now, we have not discussed any machine or even the transformer. Till now we have discussed only 2 points regarding field winding and armature winding. How we are defining the field winding? The field winding provides the working flux. So in this machine, who is going to provide the working flux? Yes or no? Stator winding. So stator windings are going to be field winding. And what is armature winding? Armature winding is that winding which is going to provide you the useful EMF or the current or the torque. So here if you see, we are talking in terms of torque. So this is going to be your armature winding, or the armature is on the rotor, you can say. I hope it is clear, Love Chaurasia. Now let us see what is left hand rule. When we will see different machines basic parts, then we will see all these things in detail. But for the time being, you please understand that if you apply your right hand rule in this way, so your index finger is going to be in the direction of magnetic field, this middle finger is going to be in the direction of current, and your thumb is going to give you the direction of force or the torque. Now you apply on this particular diagram. All of you just apply this left hand Fleming's rule and tell me what is the direction of torque on this. What is the direction of torque? I hope it is clear to all of you. Yes or no? So the idea is this electromagnetic torque or the interaction torque, how we are going to define this, please try to understand. It is very important that you understand this. The electromagnetic torque we are defining as stator field strength, rotor field strength, and sine of the angle del, sine of the angle between them, where del is the angle between stator and rotor magnetic axis. I hope it is clear to all of you. So this is how we are defining the electromagnetic torque. Now please try to understand the electromagnetic torque. The electromagnetic torque is also, why it is called interaction torque? Because the torque is generated because of the interaction of the two fluxes or the two fields. I hope it is clear to all of you. So now let us go to the next one that we are calling as reluctance torque. Now please try to understand what is this reluctance torque. Again, I have to draw one diagram so that you understand it better. So have a little bit of patience. Have a little bit of patience. You can have a little bit of patience till I draw the diagram so that it is easy for you to understand this basic thing. This is very important. Okay, so suppose these are the poles. This is north pole and this is south pole, and suppose your rotor is something like this. Now I am making my rotor something like this. Let me correct the diagram so that it looks little better. So it is something like this, suppose. I am taking my rotor something like this. Now this rotor, I am saying, it is made of some ferromagnetic material. Okay. So if you now see the flux lines, then it is going to be something like this. Because of the presence of this ferromagnetic material rotor. Okay. So what is the idea? The idea is this reluctance torque is also called as alignment torque. And it comes due to the variable reluctance. A torque is generated in the direction so that the fluxes are aligned and the reluctance is minimum. You must be knowing that if you see your electrical circuit, in your electrical circuit, love chaurasiya beta, everything is okay. Everything is okay, love chaurasiya beta. Why you are in so much trouble? It's okay, thank you very much. What is the problem with you? Now please try to understand, as in case of your electrical circuit, what is happening? As in case of your electrical circuits, we say that current always follows the minimum resistance path. The same way for your magnetic circuits, the flux always try to follow the minimum reluctance path. For that purpose, for the alignment, there is a torque generated which we are calling as reluctance torque or the alignment torque, so that the reluctance is reduced to minimum. I hope it is clear to all of you. Are you comfortable till here? Please tell me, because there is a small derivation part of the torque generated in the rotating machine that I will be discussing tomorrow, because we are running short of time. That will be going tomorrow, and tomorrow we'll be starting the basic construction part of the transformer. So till now what we were discussing was the basic understanding, to develop the basic understanding. And let me tell you some important points, all of you who have not attended my previous lecture, that by tomorrow is 23rd April. 23rd April we are going to start transformers, and it is going to be a really interesting journey and sessions. So if you are interested, if you have any doubts in transformer, you please come, we will discuss everything about the transformers. So 23rd April I am going to start the transformer. So all of you, there is one humble request. Please go and watch my previous sessions, because whatever we have story is going to be little easy for you. That is the only reason why I am telling you this thing. So I hope it is okay for you. So tomorrow we are going to take one small derivation, you can say, for the basics of torque generation in non-salient type rotating machines. Then we will be starting the transformer. We will see the basics. Tomorrow we will see, let me tell you what are the points we are going to take up tomorrow. Number one, non-salient pole machine torque equation we are going to discuss. Second thing we are going to discuss, basics of transformer construction. All these small issues that are being asked in different examinations, we are going to discuss tomorrow. Different parts of the transformer we are going to discuss tomorrow, and it is going to be really very interesting session. And third topic that we are going to start tomorrow is transformer action and the equivalent circuit of the transformer. Time is going to be same beta, time is going to be 8:30 p.m. These classes, let me tell you one more thing, that Monday to Friday 8:30 p.m. we are going to discuss major part of theory, and Saturday at 8:30 p.m. we are going to do some theory plus some numericals. So because we have covered the basic part we have covered, and we are now about to start the transformer. So this Saturday we are going to take up so many numericals. So it is going to be really enriching session this Saturday 8:30 p.m. So Monday to Friday we will be discussing theory, and Saturday we will be discussing little bit of theory and numerical. Beta tomorrow, love Chaurasiya, beta tomorrow's time is 8:30 p.m. 8:30 p.m. Is it okay all of you? So don't forget to like this session and share this video in your friends. Suppose you are having some social media groups, WhatsApp group or any group, Facebook or whatever resources you are having, don't forget to share this video with your friends and colleagues, because let me tell you that we are putting lot of efforts to bring these lectures for you. And if you don't like this page, don't share this video, what happens? We get very less number of people. As you can see, only about 10 people are there in the class. So it is very difficult. It is not kind of motivating for us to keep on making these sessions for you. So if you want more and more sessions, at least you can put a like, okay, or at least share it. Okay, so thank you so much, Raj Shekhar, Sai Kumar, Love Chaurasiya, all the candidates who were with me throughout this session, Dinesh Golapalli, Ramanan, Meena Bitala, RD, all of you, Sanjay Bonsu, Dinesh, Sunil, all of you. Okay, thank you so much for being with me, Vigneshwar. Now we will be meeting tomorrow 8:30 p.m. and we'll be discussing non-salient pole type machine torque equation and basics of transformer construction, transformer action and equivalent circuit. Thank you so much for your time, friends. Let us meet tomorrow. Now there is some important information regarding the 60 plus people, 60 plus students who have been the top rankers among the top 100 people in the GATE 2020 examination. If you want your photograph here, then you have to work really very hard. So friends, thank you so much. Prep smart, score better, go grade up, stay safe, stay in your home. Thank you so much.